Hello, in this lesson, in this clip, I like to go over the quiz questions. Um, I have graded your quiz, and there's some, minor issues that I need to go over. When we determine the domain, we do not need to simplify. I hope I make that clear. Okay, I still see people try to reduce. We did a lesson in class, and reducing is totally not necessary, and we have spelled that out. Okay, so reducing is entirely unnecessary. So let's see the first one. The first one, all you have to do is just spell out. There's not much work to be shown. And you just say x is not equal to 5. That will be the easiest and the best answer for you, nice and clean. You don't need to do more. You don't need to explain more because we know that you have a certain algebraic foundation. You know that denominator cannot be 0. But if you still want to show work, okay, I'm all for it. Show it, you know, show it, but in an organized manner. Yeah, organized manner. If you want to set up, say, denominator is not 0, and then you get x is not equal to 0, right? You draw that conclusion as well, and you're done. Or if you set it equal to 0, right? Some people learn it some way. After all, we have nearly 40 people in the class, and everybody had a, teacher before and taught you a certain way. And then you get x equals to 5. And then you still draw the conclusion of x not equal to 5. There are certain logical thinking behind this. And of course, for this one, it's perfectly okay. You don't need to say more. The second one, you indicate the denominator cannot be 0 to set up. The third one is you set it equal to 0, knowing the denominator cannot be 0. So you find the solution. So this number that will cause the denominator equals to 0 should not be in the domain. So that's how we get the domain as such. So any one of the three is good enough. So please understand you know um we don't need to do any reduction. I mean the second one. Second one, there's no need to do any factoring. Let me say this again. You don't need to do any factoring. In the classroom, I did another example and did the factoring is to make a point to tell you if you do the factoring, it could cause certain issues, could cause some problems. That's why I did the reduction. Also, the future, you're gonna see this kind of reducing is necessary, but each step has certain assumption behind it, okay? So for this one, all you have to do is just take the denominator, okay? Set it not equal to 0, and you can factor, or you can do x squared equals to 9. Solving this inequality, there are many ways, right? This is one of the ways. And forgive me, I probably will not enumerate all possible ways. Okay, so this will be the next step. The next one, if you like to be perfect and show you know some math, you take a square root, and this is how you write it. However, the square root of x squared is equals to absolute value of x. okay? I still saw the mistake that somebody or some people on the next step, they have X. That's wrong, okay? That's wrong. Obviously, that's going to cause you to lose one of the numbers that should be excluded. So the next step is because absolute value of x squared equals to absolute value of x, and that equals to 3. Not equals to 3 because we started with not equal to. Okay. And what will be the solution for x is not absolute value of x not equals to 3? Then x cannot be equal to -3. X cannot be equal to +3. So this will be the most perfect version of solution with no logical ambiguity, So then you can say domain, okay, is all real numbers, but not -3 and not 3. Now, we got some issues here. Some people did this way, but there are some changes. Okay? And this person will write ±3. That's okay. That's okay. I assume you know the domain should be x is not equal to -3 and not equal to +3. And the key word must be and. Okay, for this, I'm asking you to study the truth table lesson. Okay, it wasn't a very long lesson, but it's a very, very important lesson. However, I also see this version. Okay, this person solve it. Okay, however way they solve it. Okay, and the student writes, instead of x is not equal to -3 and not equals to 3, a right or. This will be a mistake. Okay? Because in the or relationship, if one is true, A or B, if A is true, it's true. B is true, the whole thing, A or B is true. Okay? So I recommend please to study truth table. Truth table lesson. Okay, it's very important for you to have all these logic things clear up. Okay, so why this is a mistake? This is a mistake because when you say this means that if one of them is not true, you can still make this true. That's not the case. Because in order to guarantee the absolute value of x not equals to 3, x cannot be -3 and x cannot be 3. Okay? If either one is true, then it would be true. It would be violated, right? But anyway, so there are other versions of these. For example, someone could be doing, I cannot exhaust all possible ways to do this, but just for example, someone says, okay, they set it equal to 0, right? With the logical understanding that we try to identify all the numbers such that the denominator is equal to 0 and excludes them. So someone could have done this, okay? You can do it by factoring or solving this way. And when you determine your domain, okay, see here, right? It really means x. Okay, this means that x equals to -3 or x equals to 3 are solutions to x squared minus 9 equal to 0. And the domain of it, the domain which is the opposite, right? Remember, the number that make it equal to 0 should be excluded. So we need to exclude these two numbers, which is x equals to -3 and x, or x equals to 3. So that must be, x is cannot be, because the opposite of or is and. So that's the domain. Okay, I hope you guys understand. I made much ado about this issue, and you will encounter these in the future in different forms. So it's better we understand it now. We can apply it later. Okay. So if you have any other questions regarding how to do this, let me know. On this one, really, there's not much to discuss. Okay, it just x not equal to 0. I introduced this question because this is going to be one of your homework questions when we touch limit. Okay. All right. And, one-sided limit and so on and so forth. So it's better that we know about this question and its domain in our knowledge base. Rationalizing the numerator. This one, in this case, we use the any number times one stay the same, this mathematical principle. Okay, so I want that to be clear in your head. You don't have to mention you're using it, but you should know. And when selecting the one, okay, it should be the conjugate. So you have something a minus b is a plus b. So the quantity you choose should be 9 plus h in root plus 3. I have some problems. Some people choose choose the same. Okay. That's caused the problem. That caused the problem. Obviously, this reviews the algebraic work that needs to be reviewed. Okay, so let me do it the right way first. Okay, so we basically have root 9 plus h minus 3, and its conjugate is root 9 plus 3. I saw all kinds of mistakes. Some of those mistakes is beyond my imagination. So for those of you who have made those mistakes, please do the homework. I can clearly see from your quiz work whether you've done any homework at all. Okay, this is also the purpose of the quiz, because I can evaluate and I know a little bit more about you, so I can maybe give you some advice and give you help. All right. Okay. So these two are conjugate to each other. So this is forming the case of a minus b times a plus b. Okay. And that equals, of course, a squared minus b squared. You may come in with insufficient mathematical preparation, but you have to work extra hard to make it. If you don't, well, you better be graciously facing the consequence. Okay. All right, so next we have numerator times numerator, denominator times denominator. So this addition form will be multiplying the h. So this is gone. And this piece, okay, is going to multiply the other piece. So this step is really extra. You don't need to write this step as a matter of fact. Okay, but I wrote it just for you to see better. We're doing numerator times numerator, denominator times denominator. So on this step, we're applying this property, this identity, okay? So we're getting a squared minus b squared, okay? Now, in our discussion, we talk about that if we have a root x inside the parentheses, that equals to x because the domain of the whole thing is x greater than or equal to 0. And the other one is root x squared is equals to absolute value of x. Okay, when you square inside, you square outside, the difference. Why the difference? Domain. Domain is the main reason for that difference. All right, so with that in mind, you can see I did not multiply h with the inside, just leave it like that. Okay, so here we're gonna have 9 plus h, and 3 squared is 9, and 9 minus 9 makes 0, so the next step we have only h left, and this h and the next h will reduce. So in the end, we got 1 over root of 9 plus h plus 3. That's the end. You can choose to have just the 3 steps in it. And I might have presented too many steps because I want to take care of everybody. You don't have the same number of steps. Okay, common mistake I saw. A common mistake I saw. Mistakes. Okay. I saw multiple work that chose choosing the same thing. Okay. In truth, judging from mathematical principles perspective, as I told you, that's how we grade. That's how we judge your work. We don't judge you, we judge your work. Okay? So in this case, if you choose the same quantity, on this step, there's no mistake. There's no mistake. Okay? There's no mistake because you multiply by 1, right? Anything times 1 is stay the same, but it does not violate mathematical principle. And however, this person did the following. All right? This person will multiply the numerators with numerator and still get that piece. And that is a terrible mistake. This is the mistake. This is a mistake. Why is a mistake? Then this equal sign is no longer validated. Why this is a mistake? Because this piece, okay, because the numerator, okay, now I'm just taking out the numerator time the numerator is a square. Okay, this piece is different from this latter one if you have plus. If you have plus, if you have multiplied the conjugates, this is what you got. Okay, this is what you got. But if you multiply, so let me bring this down over here, show them more space, right? So if you multiply this way, you can see they are different. You see that difference? Okay. And what would this be? what would this be? Just to recall, this is A minus B times A plus B. So that equals to A squared minus B squared. And now what do we have here? We have A minus B, A minus B. Wait, sorry. Okay, we have A minus B. Where's my mouse? Okay, here. Multiply A minus B. Ooh, what's going on? Hold on. I'll fix it. I can fix it. All right, so A minus B times A minus B. A minus B times A minus B is A minus B squared. Okay, so the mistake made was telling the reader that A minus B times A minus B is A squared minus B squared. That's not true, right? So what is A minus B squared? If you FOIL it, you're gonna get A squared, oops, minus 2AB plus B squared. Okay, and that's gonna be equal to, you have this part, all right? Okay, you also have a 2AB, 2 times A times B, B is 3, and you also have a plus 3 squared. You don't have a minus 3 squared. You have, well, you can see these two are different. When you make a mistake like that, it's over. It's over. Okay? All right, so don't make this kind of mistake. It's very common, and we have addressed these kind of mistakes many times. So please, please, please get a piece of paper, get pencil, and do it. Okay? You have to do it. You have to do it. So it will become yours. So this is a mistake I saw multiple times in grading your paper. Okay. Last but not least, this seemed to have inspired much discussion, which I'm glad to hear. And some people not get it completely right on the quiz and keep on working on it, and later on send me the solutions, even though that's not going to change his or her grades, but I still appreciate the effort. I encourage you guys to do that. Okay? The end of the quiz is not the end of the study. All right, so let's see what we do. Okay? One of the ways I saw some of you prefer to do is this way. So I'm going to do it that way too. I'm going to follow this way to do it. I will show you another way. So if this way of writing helps you to see better, which these two are the same, that's great. That's great. Okay, so let's work it this way. And next, we're going to find the common denominator, right? Obviously, the common denominator, LCD, least common denominator, is just x squared multiply x plus h squared. That's the least common denominator we got here, right? So we're gonna use it. So let's move forward. Okay, so on this piece, I'm gonna multiply x squared over x squared. On the next piece, so the principle I'm using is mathematical principle number 1. You can see mathematical principle number 1 is used many times over, very often, very often. So we got the common denominator, okay? Now we have the same denominator, so we're gonna we're going to keep it. We're going to keep it. So we use the common denominator. And what do we get now? Right? We got x squared times x plus h squared. And the numerator, 1 times x squared, that's x squared. Subtracting x plus h squared. That's it, right? Of course, it's not over. It's not over, okay? And what can we do about reducing this piece? Of course, we can do something to reduce it, okay? We are going to multiply or FOIL the latter square, okay? That's going to give us x squared plus 2 times xh plus h squared. Okay, all right. Next, opened up the bracket. So everything in the bracket change sign. So minus, minus. And reduce. You can see x squared, oh, whoops. I'm sorry, this is a minus, and this is a minus. So x squared minus x squared, that makes 0. So we have negative 2xh minus h squared. Here, these two fractions are separated. Okay, if you bring them together, you will need a parentheses. Okay, so in this form, we actually can factor out an h. So I am going to factor out an h. So one of the h is being taken out. So this h is gone, and this one of the h is taken away, so we get that. And this h and that h will reduce. So in the end, we got the following. H and h taken away. That's the final answer. That's the final answer. Okay, so let's look at another way to do it. The other way is some of you might prefer to work with a complex fraction. If you like to work with a complex fraction, you must make sure, okay, you must make sure that you know which one is the big numerator and which one is the big denominator. In our case, this whole thing is a numerator, h is a denominator, so this fraction bar, the thickest one, should be in or on the same level as equal sign. Okay, I saw people confused with that, and it caused consequences. So we still use the same common denominator. So we still have the same LCD. Okay, we still have the same LCD. However, how we're gonna, what we're gonna do to, how do we make use of this LCD? Okay, we're gonna multiply. I'm gonna show you a sequence of actions. So you're gonna see that still multiply 1, right? So this whole quantity is 1. I'm using mathematical principle number 1 more time. And numerator times numerator, but numerator times something in subtraction. So in this case, I can write it by distributive law. I'm going to take this piece, right, to multiply that, and to multiply, the second one is being subtracted by. And the latter one, the denominator times denominator. And there we go. Okay? And here you can reduce it. You can reduce it. And x plus h squared in the denominator and x plus h squared on the numerator, so these will be reduced. And 1 over x squared multiply x squared, that will be reduced to 1. So essentially, we got the same thing as we did here. You see that? Okay. And then, of course, you're gonna proceed with all of that. So the answer would be the same. So either way, okay. All right, if you have any questions, please don't hesitate. Now, I'd like to give you some feedback about this. This is our very first quiz. Okay, I want to investigate how prepared you are. If you have trouble with these algebra, you need to work hard. You need to work extra hard to catch up because these algebras were from elementary algebra, intermediate algebra. And you still have time to, to catch up. If you don't, there will be even more complex algebras ahead of you. There will be even more complex algebra ahead of you. So please do yourself a favor, study hard at this point, and I will see you soon. Thank you for watching.